A farmer has 200 meters of fencing to create a rectangular enclosure. What dimensions will maximize the area of the enclosure? So this is the idea of optimization problems, which is 511 here. The idea behind an optimization problem is you are trying to take an equation, take the derivative of it, giving you critical points, and critical points give you a local maximum or a local minimum. So let's start out with what we know. We have a rectangular fenced-in area, so this is me doing the best I can drawing a rectangle, and I did a decent job here. We'll call you length and width. And we know that we have 200 meters to work with. So using the information we learned from elementary school, 2 times length plus 2 times width is equal to 200. That's my perimeter formula. Now, what I'm also trying to do is maximize the area. So another equation that I could use is A equals length times width. Now, my job is to maximize this, which means I want to take the derivative of that. Right now, I don't want to because there's 2 different variables. Oh, but since I have this equation, I could solve this equation for like L or W, plug it into that guy, and I only have 1 variable to deal with. So let's do that. Let's solve it for W. Let's subtract 2L, cross U out. 2W equals 200 minus 2L, like so. Divide everything by 2, divide everything by 2, divide everything by 2, cross U out. W equals 100 minus L. So now what I can do is I could take that equation and that information and create a brand new equation. Even though I put the arrows there, I'm going to put it way over here. A is going to equal instead of, well, I'm going to keep LL. And instead of W, I have 100 minus L. Distributive property tells me that A is going to equal 100L minus L squared. Now let's take the derivative of that. A prime is going to equal 100 minus 2L. In order to find the critical points, you set it equal to 0. So 100 minus 2L. Let's add 2L to both sides. So let's move this up here. 2L equals 100. And my one and only critical point is going to happen at 50, which means 50 exists at a maximum or minimum. And in this case, it's going to be a maximum because the numbers make it work that way. Now, if the length is 50, I need to find the width. Up here, it says that the width is 100 minus L. So the width is going to be 100 minus 50. So the width is 50. My job is to maximize the area. Area is length times width. So area in this case is 50 times 50, which is 2,500. So it's going to be A. Now, a fun fact, if you're given a rectangle and all 4 sides to make fencing out of, your maximized area is always going to be a square. Always, always, always. Now, later you'll see me do a problem where I have the fencing holding up against a barn, where I only care about 3 sides. That's not going to be the same. But in this case, we get a square, and that makes sense. Yes, the old open box volume problem. You will see this in every calculus class. A manufacturer wants to create an open box by cutting out squares of size X from each corner of a rectangular piece of cardboard measuring 8 by 10. So, there's my cardboard. This is me cutting out an X, cutting out an X, cutting out an X, cutting out an X, 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 X is everywhere. X is everywhere. Now I know that one of these sides is 10 and one of these sides is 8, which means after I cut things out, you're going to be 10 minus X, so 10 minus 2X, and you're going to be 8 minus X, so 8 minus 2X. When I take these sides and fold them up, that gives me a box with an open top, right? Where the height is going to be X, the width is going to be 8 minus 2X, and the length is going to be 10 minus 2X. So this is where the fun begins. My job, after cutting the squares, the sides of the box will be folded up to form the walls. Yeah, I kind of got that. What size X squared should be to maximize the volume of the box. So this is where it gets tricky. The volume of the box is going to be X times 10 minus 2X times 8 minus 2x. Okay, so let's multiply stuff out. The volume is going to be 10x minus 2x squared times 8 minus 2x. Let's FOIL stuff out. 80x minus 20x squared minus 16x squared plus 4x to the third. And that's my volume formula. Now what I need to do is I need to take that volume formula and take the derivative of it. That's going to help me find maximum or minimum values. Okay, so the derivative, actually, you know what, let me clean this up a little bit. Let me put it in order, put it all together. That would probably be a smarter idea. 4x to the third minus 36x squared plus 80x. Okay, and I got that negative 36 by combining these guys right here. Now I'll take the derivative. When I take the derivative, that gives me 12x squared minus 72x plus 8. Set it equal to 0 to get me critical points. And what I'm also going to do while I set it equal to 0 is factor out a 4. 3x squared minus 18x plus 20. Now the frustrating things about these types of problems and what we're left over here is you can't factor that. It's a mess. So we're going to use our dear friend, the quadratic formula. I'll call you A, I'll call you B, I'll call you C. X equals negative B plus or minus square root B squared minus 4AC all over 2A. And we'll plug in our friends. Negative 18 plus or minus, the square root of negative 18 squared minus 4 times A, which is 3, times C, which is 20. All over 2A, which is 2 times 3. All right, so the double negative 18, plus or minus 18 squared is 324. Took me a minute there. Negative 4 times 3 is 12 times 20 is 240, but the negative version of it, all over, that'll be 6. This guy simplifies out to 84, all over 6. You can pull out a 4, which means you can pull out a 2, so 18 plus or minus 2. If you get rid of the 4 in there, you're left with, oh, no way, my favorite number, 21, all over 6. Now, I'm going to quick run to a calculator and type out what this guy is. Oh, by the way, no, I won't. 9 plus or minus the square root of 21 all over 3 because I can simplify all those even numbers. Now I'm going to go off to the side and see what I get. All right, so I got x equals, give or take, 4.53 and 1.47. One of these numbers can't make sense, and it's u. U can't make sense because if I were to say, all right, yeah, let's cut out 4.53 out of this thing, you would have 8 minus like 9, which means you would have negative box. That doesn't make sense. So our only feasible option is that 1.47. So that's the only guy we're going to be able to get. Tricky stuff. Quadratic formula is never fun, but you need to know how to use it, so this is us using it. Happy times. A farmer wants to create a rectangular fenced-in area against the side of a barn. The farmer side of the barn, rectangular fenced-in area. The farmer has 40 meters of fencing available and will use the side of the barn as one side of the rectangle. Let x be the length of the rectangle perpendicular to the barn, so u, and y be the length parallel to the barn, so u. Okay. And again, our job is to maximize the area. Okay, so when you have a problem like this, you need to come up with as many equations as you can. I have 2 x's and a y giving me a perimeter of 40. So there's my perimeter formula. Okay, I'm also supposed to maximize the area, so the area is going to be x times y, which means I'm going to want to take the derivative of this. But I can't because I have two variables. Oh, but you know what? Since I have this information, I could just subtract 2x minus 2x like so, get y equals 40 minus 2x, and then replace that y with 40 minus 2x, and then I have one variable. So a is going to equal 40x minus 2x squared. Now we take the derivative of that, because taking the derivative will allow us to find critical points, which gives us maximums or minimums. Okay, so a prime is going to equal 40 minus 4x. Set it equal to 0 to find my critical point, so 40 minus 4x is equal to 0. Add 4x, and 4x will equal 40. Divide by 4, x is 10. And if x is 10, that means I could use that equation right here to find out that y equals 40 minus 2 times 10, which is 40 minus 20, which is 20. So y is 20, x is 10, even though I wrote 0, 10, and 20 gives us the answer of A. Now, in a previous problem, you saw me do one where I gave you all four sides of the fence. That answer was a square. This one's not, because I'm not using all four sides of the fence. Fun stuff. The amount of food in grams consumed by a goldfish each day during its lifespan of 20 days is modeled by the equation f of t equals negative 0.1 t squared plus 2t plus 20, where t is the number of days. During which day will the goldfish consume the most grams of food? So we need to maximize this guy right here. Well, in order to maximize something, we need to first take the derivative. So I'm going to take the derivative, and that's going to be drop down that 2, negative 0.2 regular t plus 2 plus nothing. In order to maximize it, we set it equal to 0 to find our critical point. So 0 is going to equal negative 2t plus 2. Let's add 0.2t to both sides, add 0.2t to both sides, so I have 0.2t equals regular 2. Let's get a different color in here because why not? Divide both sides by 0.2, divide both sides by 0.2, and t equals 10, my only critical point, which means the time 10, or in this case day 10, is when Mr. Goldfish is going to consume the most food. Good for you, Mr. Goldfish. Live your life.